So what is happening is when you're starting the when you're starting the loop, right? So at that point, what happens is I'll start. Is that network name? The network name is home dash whatever, right? No. No, that is not. Oh, okay. Yes. And everything, yeah. So 25F93C5. Okay. Okay. So we'll start with. Okay. So. Yes. So there's another question that is asked is that there is two linked lists, and you have to figure out that if there is a both of these lists intersect or not. If they intersect, return the node which is intersecting. Right? So there can be two cases. Right? So let's say this is list 1, this is list 2. In this case, they do not intersect. Right? There will be another case. In which this is list 1 and this is list 2. In this case, they are intersecting at this node. Right? So we have to return an intersection, like intersection word. In this case, we'll return null. In this case, we'll return intersection. Right? So how you do it is. Okay. So how you do it is basically you will find the length of the first one and length of the second one. So let's say in the length of first one is 1, 2, 3, 4, 5. The second one is 1, 2, 3, 4, 5, 6, 7. So this is 5 and this is 7. Okay. Now 5 and 7. Now what you will do is you will actually this is the bigger part. So you'll actually increase this pointer by 2 by 7 minus 5 is equal to 2. So you'll increase this pointer by 2. Right? So now there is a pointer node 1 which is here, and there is a pointer node 2 which is pointing to the head of this. And now you will keep increasing both of them one by one. If either of them reaches null, then that means there was no intersection, you return null. If they meet, then you return that. Yes? Easy?
Yes.
Okay, good. So we will write code for that. So this function should be outside the class because we are sending two of them. Okay. A list node star get intersection, and it gives a link list star list 1 comma a linked list star list 2. Okay. So now we will have we'll get a list node star intersection. I probably don't need this. Anyways, so we'll take integer length 1 is equal to list 1 arrow get length. Integer length 2 is equal to list 2 arrow get length. Okay. Then we will check. We'll get the head node. So we'll say a list node star node 1 is equal to list 1 arrow get head node. I have like a function get head node which returns the head node. Star node 2 is equal to list 2 arrow get head node. Okay, so I get the head node of both of them. Okay, we will check if length 1 is greater than length 2. In this case, for int I is equal to 0, I is less than length 1 minus length 2, I plus plus, node 1 is equal to node 1 arrow next. Okay, so we will increase the node 1 if the length of the node 1 is greater, else for we'll have the same thing over here with length 1 minus, it will be length 2 minus length 1, and this will be node 2 is equal to node 2 arrow next. Okay, so at this point, if node 1 if the first length was bigger, we moved the node 1 by the difference. If the second was bigger, we moved that one by difference. Okay, I will erase this because otherwise he can't see what. So I'll from the top. Can I do that?
From the top.
From the top. Okay.
After the fall. Yeah.
Okay. Anyways, so that has happened, and then what we will do is while node 1 exists, okay, if node 1 is equal to node 2, node 1 is equal to node 2, then intersection is equal to node 1 or node 2 or whatever, and we break out of this loop. Okay. Otherwise we will say node 1 is equal to node 1 arrow next. Node 2 is equal to node 2 arrow next. Yes? Yes? No? Do you guys understand this? Yes? Can I move forward, like, to the next question?
We might even want to check what to write in the while loop, because in while loop we also
We don't want to, because at this point, both of the length are the same, right?
like
So if node 1 becomes null, node 2 will also become null. Right? So either way, we don't have to check both of these. So we got the get intersection. Okay. And we will do a sorted merge. Okay. Okay. So let's say there is two linked lists. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So there's two linked lists. Both of them are sorted. So both of them are sorted at this point, and we have to merge these so that the merged list is also sorted. So this list becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Yes? There's less time, so I will actually give the solution, and like if you have questions, I'll explain those questions. I want to do as many questions as possible, so I'll write.
So this will be just comparison of first groups, or?
No, you have to merge these two lists and return a list which is the merged list.
Yeah, but the logic will be comparison of first node of first list and second.
Sure. Yes. So I will write the code. It is a recursive solution, and it is actually a very easy solution. Once you see the solution, you will get it. Like it's very, very easy. Okay. So
And we are assuming that list 1 and list 2 are already sorted.
sorted. Yes, it is sorted. It is given to you.
Okay.
So a list node star sorted merge, and it is taking a list node star node 1 comma a list node star node 2. Just taking 2. Okay. We will say a list node star result is equal to null, in case everything is null, right? So in case both of them are null, we are returning null. Okay. We will check. To check the first condition, that if node 1 is null, so which means that node 1 is null, the first list is null, all we have to do is return the second one. So if not node 1, return node 2. Okay. If not node 2, return node 1. Yes? So far so good? Okay. Then we will check the condition. If node 1 arrow data is smaller than node 2 arrow data, which means that node 1's data is smaller than node 2 data, then the merged will actually be, we will take the first one. So we will say result is equal to node 1 and result arrow next will be equal to sorted merge of otherwise result is equal to node 2 and result arrow next is equal to sorted merge node 1 comma node 2 next. Yes? Is this simple? Yes.
So what do we return in this? What is the
Yeah, return result.
But will result be the head of the sorted list?
Excuse me?
Will result be the head? Will be the head of the sorted list?
Result will be the head of the sorted list, yes. Yeah, I have written this code, like you can write this code and once you debug through it, you will actually understand that what is going on. So if node 1 is null, you return node 2. If node 2 is null, you return node 1. Otherwise, if node 1's data is smaller than node's 2 data, which means that we have to result, we have to add node 1. So we say result is equal to node 1, result arrow next is equal to sorted merge of node 1 arrow next, comma node 2. Otherwise, result is equal to node 2.
So if it's equal, we're just going into the else.
If it is equal, we are just going to the else. It doesn't matter. So, okay. So I will move on to a different question, which is a question in another book, which says that you have to zip line. No. Say 1, 2, 3, 4, 5, 6, 7. That's 7. Now zip line means I'll take 1 and then I'll take 7 and then I'll take 2 and then I'll take 6 and then I'll take 3 and then I'll take 5 and then I'll take 4. Yes. Zip line, that is what they call it, like zip line. So basically you'll take this one and then you'll take this one. And then you'll take this one and then you'll take this one. And then you'll take this one and this one. And then this one. Right? Yes. So, did you guys understand the problem? Zip line. Last. Did you guys understand the problem? Okay.
So like the question is like you want to navigate using the second list. Like based on the second list, we'll be navigating.
No. We don't have to navigate. This list transforms to this list.
Okay.
This list becomes this list. That is what we are saying. So, that is the question. Okay. I think we have done separate questions which we can use to do this. Okay. How we can do this is we will actually break this over here. Okay. Now we broke that over there and we reverse this list. So this becomes 7, 6 and 5. Now what we do is we'll take one from here and one from here. It is the sorted merge. Like the sorted merge, we will actually change that merge. Okay. So I will write the merge one first. Did I write the merge? I don't know. Yes. So I will write the function of the merge, and then I'll write the function for the breaking of the thing. Did you guys get this? Yes? No? Okay.
I think probably like before
Yes.
coding it, what Jack explained, like, you can tell us the thing.
Yes.
No,
the
not
stack.
coding it, like
Ah.
using the stack and how do you solve it actually?
He did explain it.
Or
He explained.
Explain what?
He explained another way to solve it.
Oh, okay. Using a stack?
Okay. Yeah.
Using a stack? Yeah, you can use it. Yes. You can use it using.
Depends on time complexity, right? Stack is of.
No, but stack will take extra space.
Yes, but it will take extra space.
Stack will take, this will not take extra space.
Take extra time.
Yeah. So we can do it with stack also. Stack is an easy solution.
How do we do that? Can you just tell the logic?
1, 2, you tell me. 4, 5, 6, 7. Okay. Now you tell me how to do that. So we find,
Push everything to stack.
push everything in the stack.
Everything.
Till half.
Half.
Okay.
And then pop and then.
So 1, 2, 3, 4.
5, 6.
So from the back.
In a linked list, you cannot do that, right? So 4, 5, 6. Do we have to do that? I don't know.
Half.
Even with half, how will we reach till 7 then?
Okay.
We probably have to start from half.
Yes.
Okay. So we start from half. So we are at, so it will be 5, 6, 7. We reach the half, we break it, right? So this becomes null.
Pop it out.
We take 1 and then we pop this out and put 7.
Basically, stacking is doing the reversal for you. Pop, pop,
It's
is doing
just,
reversal.
yeah, the algorithm remains the same. It's
Algorithm.
just reversing the list.
Yes. But the thing is, this uses a stack. I'm not using extra space.
So extra space means since you create is stack, so extra space. Right?
Yeah, because stack, yeah. So if, let's say if this was a million long, right?
So we
In
can
that
put
case,
space in there.
yeah, you will have like 500,000 of this. So that is not. Okay. So we will write the function for zip merge. So a list node star zip merge, and this will take a list node star node 1 comma a list node star node 2 comma boolean switch. Okay, it's taking a boolean switch. Now what we do is we will check a list node star result is equal to null. Okay. If not node 1 return, you guys can tell me what I have to write. If not node 2 return node 1. Okay. If switch result is equal to node 1 and result arrow next is equal to zip merge of node 1 arrow next comma node 2 comma false. Yes. Else result is equal to node 2 result arrow next is equal to zip merge node 1 comma node 2 arrow next comma true. Yes. Yes. You guys understand? At least the, so one time it will come, B switch is true, it will add node 1 and the next it will call with the false. So next time it will come, result will be node 2, so it will take 1 from node 1, 1 from node 2, 1 from node 1, 1 from node 2 till everything else. So this is the function for zip merge. Now we will write the function.
1 minute.
Yes. Sorry. I will send it to Coco. Yeah. Okay. now we will write, so the original question was we were zip lining. So, void a link list colon zip line.
What's the question now?
The question is the zip line. So ye to sorted, this was sorted merge. This was zip merge. But we have to first break the loop, break it in half, and then reverse the second part, and then call the zip function, right? I don't know, should I write that whole function or?
I think we are fine.
You guys have the logic, so you can, yeah. Okay. Okay. So we did the zip list. So we did the zip list. Now we did a sorted merge. Now we do the removing brackets. Get into section, sorted merge, having to this, okay.
You can explain some better logic for sorting list.
Sorting a list will do it tomorrow. So I have a like tomorrow we'll do sorting of the list. Okay. Removing duplicates. Okay. So there is another question which is that if there's a linked list, you have to remove the duplicates. Right? So. One, two, 3, 4, 3, 5. Right? So you have to remove the duplicates, so this list will become 1, 2, 3, 4, and 5. Right? That is what you have to do. One easy solution is, you guys can tell me, easiest solution. Sort the list, that is n log, yes, you can do that.
The next step, change in.
Yes, you can sort this list, but then when you sort the list, the order will not be the same. Right now I have written it in the same order, but if let's say it was 2 and 1 was here and 4 was here, in that case, one will start coming to the start. So,
But we can start with the first node and
Okay.
then keep moving.
Okay.
We will map first node with all the nodes. Anywhere if we find it, again moving back to the second one.
that is an n square solution, that is what I am going to do. Another easy solution is you can actually have a hash table. So add the values in a hash table, go to the hash table and figure out, okay, whatever is there, just, yeah. That's, I don't know. Not
We can also take 3 pointers and do edits.
Okay.
For a long time.
I actually did not see that. I don't know that
Which
solution.
is out of N.
Can you tell me actually that might be good. So 1, 2, 2, 3, 4, 3, 5. Okay, now how do we do that?
need to take 2 pointers at head and 1 pointer. Tomorrow I can tell I did it actually.
Okay.
In the next next pointer, like if the 2, we can take another pointer. If I will compare like this. It will be order of an. Tomorrow I will tell them.
Okay.
Now back I did it actually.
Okay. I actually I don't know that solution.
Yeah.
And
Whenever the duplicate number will come, we will remove it and we will attach to the. We will take the temporary another pointer and we will point to the next link and we will remove that node. We will read
but that will only work in the sorted, right?
No, I will.
How will it?
I did long back actually.
The question is you have to remove duplicates, right?
Okay.
So yes, I can do that. Like if you have one pointer over here and another pointer, and keep comparing the next pointer, and if the next is the same, then you delete it. That will be order of n. Yes, we can do that. But if it is not sorted, I don't know how to do that. Maybe there is a solution. If you can let me know that
Yeah,
tomorrow. We'll
Yeah.
So tomorrow is linked list.
So the one she is saying is there own mission?
Is the That's what she
when
said.
it is sorted.
But it won't be sorted.
Without sorted.
Only when it's sorted. Without sorted, I don't think you can.
I don't think you can do it, but
Yeah.
but if there is a solution, yes, I would definitely want to know.
Yeah.
You can use a hash table.
The hash table is
space.
Yeah.
yeah.
Complexity goes insane. at
Oh.
that point.
So another solution is the solution that you said is like keep a pointer current and then keep running it till the end. And if you find a 1, then delete it, then go to 2, go it again, go over this again, you find a 2, delete that, and you continue. Okay, I will write that's a pretty simple solution, but
But again, we need to sort the.
no, we don't need to solve.
But it will be the same.
Okay, it's
Can you
recommended
take
to
it?
sort the task.
Yeah, it will not.
2 papers.
Okay. Anyways, I'll write the solution. It's 11:40, so I want to do 2 more questions. So void a link list colon remove duplicates. हाँ जी. Oh. If head or, we can check if head or.
This is only when it's
Okay. So if head does not exist or head arrow next does not exist, then there is no duplicate, so we just return. Otherwise, we take a list node star current is equal to m head. Okay. And then we will do while current exists. While current exists, we will take another node which will be the runner, which will go to the next one. So we'll say a list node star m is equal to current. Okay. And then we'll start while temp arrow next exists. Okay. We will check if temp arrow next arrow data is equal to current arrow data. Right? If the next one's data is equal to current's data, then we have to delete the delete that one. So we'll say if that's there, then we will say a list node star del is equal to temp arrow next. Okay. Temp arrow next is equal to temp arrow next arrow next, and we'll delete. Okay, so we've deleted the other, and we'll say temp is equal to temp arrow next. And when this loop is over, we'll say current is equal to current arrow next. Okay, so current arrow next. So this is an n-square algorithm, and it will not use any extra buffer, and we can do that.
It's more generic basically, because if the data type changes, then the hash table needs to change as well. This
Sure.
one would be.
Yeah, this is like a general, yes, it will work kind of thing. Okay, so we did remove duplicates. Reverse every k elements, and I think I did most of them. Add to this, yeah, retain and delete them. Okay. So the question is there is the question is there in that in her book, like she who shall not be named, that you have to add 2 numbers. Let me see. Did I have the solution? I think I have the solution. After this, yes. Okay. So, can I remove this? Okay. So the question is, let's say 7, 1, 3, now. And next number is 2, 3, 5. Okay. You have to add this in a reverse order. If you want to add it with 7, 1, 3 plus 2, 3, 5, it will actually be more difficult. So the question is that this is one list, this is another list. You have to add 3, 1, 7 plus 5, 3, 2, and then this is 9, 3 plus 1, 4, 5 plus 8. So it becomes 849, and you have to return, reverse this, so it becomes 9, 4, 8. That is what you have to return. That's what the question is. Okay?
If
Why
it is
don't we
5,
do a reverse?
If you do not have to do the reverse, yes, you can do it, but the question actually becomes more difficult. You try it out, it will actually become more difficult. I'll take the same example which she did.
The final result is like 849.
I will give you that once. Give me a second. Yes.
What did we have carryover?
yeah.
Carryover, we'll take the case of the carryover. Okay. So it is 71659.
I can tell that.
Okay.
Kumud, I can tell actually that thing. If
Okay.
anyone asks you like add two numbers, okay, basically we are doing the addition from the right side. From the childhood, what we will do, take the two numbers, we will do the addition from the right side.
Yeah.
So we are reversing the number and doing addition. Here in that example, she already given reversed. So we no need to reverse the linked list, both the linked
So,
list.
yeah.
Okay.
So what you
only problem I see over here is
Yeah.
because if I am going to do the addition from left to right,
Mhm.
I won't be able to do the carryover. If I am doing it from right
He
to
is
left,
telling
then I am
that-
going to do the carryover.
No, here the number is actually 317, but you are given already.
Yeah.
So
seven.
basically,
Already
like
given
if
the
you
reverse
add
number.
317 to 532, how
Yeah.
do you start it? You actually start with 7.
Yeah.
You don't start with 3, right? So that's why she actually gave you 713.
Okay.
Yeah.
But
You can always reverse.
you
it.
can always reverse it. If the question is that you have to do 3 plus 5, reverse the linked
Reverse
list
the linked list and do it.
and do it and then reverse it
Yeah.
back again. Okay? Okay. So I'll write the question and the solution, and you guys should be able to figure it out. It's pretty easy, just simple. So A link list star add to list, and it is taking a list node star node 1 comma a list node star node 2. So it's taking 2 nodes. Okay. First we'll check if not node 1. Huh? So if not
So
node
what
1,
color?
we can just say list. Okay. If not node 1, return node 2. If not node 2, return node 1. Yes? Okay. Where was I? Okay. So a link list star list 3 is equal to new a link list. So let's say we are returning. I think we are like the question that I did was with the linked list. So you can change this. Okay, anyway. So we are returning a linked list. We need different things. So we need integer carry is equal to 0. At this point the carry is 0. And integer add value is equal to 0 at this point. Okay. And a list node star temp 1 is equal to node 1. A list node star temp 2 is equal to node 2. Okay. So we will do while node 1 arrow next exists or node 2 arrow next or temp 1 or temp 2, sorry. Temp 1 and temp 2. While temp 1 arrow next exists or temp 2 arrow next exists, what we will do is we will say integer value is equal to carry. We will first take a carry, add it, and then we will check if temp 1 exists, then we will say value is equal to value plus temp 1 arrow data. Right? If temp 2 exists, then value is equal to value plus temp 2 arrow data. Yes. And we will say add value is equal to. So now initially let's say the value was 0. There was, let's say, 7 plus 5 we were adding, right? So we'll temp, so it is 7, 1, 3 and 5, 36 or something, right? So we have to add 7 and 5. So value is equal to carry, carry was 0, temp 1 exists, value is equal to 0 plus 7, and temp 2 also exists, so 0 plus 7 plus 5, which means that right now the value is 7 plus 5, 12, right? V will is equal to, now in that case there will be a 1 carryover, right? So we will say add value is equal to value percentage 10, right? So we will get 2, that is the add value, right? We will check if value is greater than 10, which means if this was greater than 10, then carry is equal to 1, okay? Else carry is equal to 0, right? And what we will do is list 3 arrow add tail add value. Okay, and we will return the list. So the condition where 7, 1, 3, 4 is there, right? So let's say if this is null, we will still continue in this loop till temp 1 exists or temp 2 exists. We will get the value, we will add carry to it, we will add the temp 1 data, we will add temp 2 data. If it is become bigger than 10, the add value becomes percentage of 10. If it was greater than 10, then carry is equal to 1. If it otherwise carry is equal to 0, and we will continue to do it.
We can avoid this last exercise by just doing a simple integer definition.
Sure, we can do. Did everyone get this? I'm doing this because like this is in that book, so whatever is in different interview questions book, like we should cover all those questions so that Okay. So we did that. Then there is reverse every k elements is there and retain and delete n. Okay, we'll do a retain m and delete n. So the question is that 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have to, let's say, retain 2. So m is equal to 2 and n is equal to 1, which means that we have to retain 2 elements, delete the third one. Retain 2 elements, delete the third one. Retain 2 elements, delete the third one. So this list becomes 1, 2, 4, 5, 7, 8. Yeah? Yes. So it's not a difficult question, it's just a straightforward, there's a brute force, straightforward solution, order of n. Unless you guys can think of something other than that, but I think this is a straightforward question. So, okay, yes. Should I start write the code? Like, you guys understand how it is going to be done, right? Link list colon retain m delete n integer m comma integer n. Okay. So there are some error conditions and boundary conditions and stuff like that. I wrote this code a long time ago, so I don't know. I think there might be a bug in this. But like, if there's an error condition, let me know. I'll send you the solution. So you will. I'm hoping that you guys will return, like, give me the code. Okay. If m is less than 1 or n, I should not even have to do that. I can just say u int. So I just get the positive values. A list node star temp is equal to m head. Okay. Boolean b first is equal to true. I think like switch or something, like why I'm taking it is like first I'm having a switch that okay I have to delete, I have to retain, and then I'll make this as false. So I can either use b first or b switch or anything. Okay. While temp exists, I will go through the entire list, and for retaining, so now I will retain. Okay. For int I is equal to 0, I is less than m, I plus plus. What am I doing? If not temp does not exist, break. Okay. Otherwise, if I is equal to m minus 1 and switch, then switch is equal to false and break. Okay, and temp is equal to temp arrow next. So over here what I'm doing is I'm actually retaining these elements. So I'm going to the next, and I'm checking if this is m minus 1 and the switch is there. I think like I probably didn't needed this, but we'll see. But I wrote this a long time ago, so I don't know. Okay, so I retained these elements, now I have to delete. So if I can erase this part. I will actually write this code again and probably have a better solution, but because I think this can be optimized. But anyway, so if not temp, break. So if the temp does not exist, you break, and now we have to delete. So for int I is equal to 0, I is less than n, I plus plus, we will say a list node star del is equal to temp arrow next, and then we'll say temp arrow next is equal to temp arrow next arrow next, and we will say delete del, and we will say if not temp arrow next break. Okay, it's a long tedious kind of a thing. Like I think I can have a better solution than this one. There is I should not have taken 2 while loops, but yes, I mean the solution is easy. You guys understand this. Okay. So these are the questions that we did today. Like we did a reversing of a linked list. We did a palindrome, finding out if it is a palindrome. We found out if it is a cyclic or not. We found out the start of a cycle. We found out if there is intersection of 2 linked lists. We did a sorted merge. So 2 linked lists are there. We merged them, and then we did the addition of two lists, adding the add operation. We did the retain m, delete n. I will send this to you. If you can write a solution and send me back a better solution, that will be highly appreciated. We did the remove duplicates with no buffer. So there was no buffer, it was n square. And if you have a solution better than this, let me know. Yes, and I think the homework should be that, okay, if there is a linked list which is sorted and it has duplicate, so remove duplicates of a sorted array, sorted list. So there's a sorted list and you have to remove the duplicates of it. That's okay. Yeah, that's okay. Okay, and we did the zipping of a list, zip line of a list. One question we did not do is reversing every k element. So every k elements you reverse them, and the next k elements don't reverse them. Next k elements reverse them, next k elements don't reverse them. Can you guys tell me how to do that? I don't want a space complexity. Like space complexity can be anything. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have to reverse reverse every 2 elements. So 1 and 2 would become 2 and 1, and then 3 and 4 will not be reversed. Then 5 and 6 will be reversed, so it becomes 6 and 5. 7 and 8 will not be reversed, so it becomes 7 and 8. Yeah?
So k value is 2, right?
K is 2. K.
So every time put it in a stack, then take it out and then
Yeah.
We can do
Yes. The 2 solutions, the one solution that I had over here was like take a stack, put 1 and 2 in there. So take 2 pointers because we want to know where to start. So we take from here to here and put them in a stack, and then we reverse them, and then next one we don't do anything. Next one we put them in a stack, reverse them, and do that. That is one solution. Another solution is pointer manipulation, in which you actually have a reverse function which starts from 1.
yeah, that we do.
Yes. Reverses k elements. So which takes, we did not do the k one.
Yeah, so the reverse function which we did, instead of checking null, we can check the
Check the k value.
Yeah.
So they can be 2 homework question. One is reversing reversing the k elements. Yeah, so we can do that. Tomorrow we'll do a cyclic insert in a cyclic thing, and probably skip this if I can get time today and do that. And what else? Sorted insert, and there's a bunch of questions. Really good questions. I think by the end of tomorrow, you guys should be able to, did you understand this? At least did you understand this thing? So if, yeah, by end of tomorrow, like I think it should be, so by end of tomorrow, you should be able to understand all the linked list questions, and you'll be like, at least the linked list questions you'll be able to solve. Okay, thank you, thanks a lot. Take the donuts home. I really don't need it. Like, I'm too overweight. This is the heaviest that I have been in my entire life. So I cannot afford to be any more heavier than that. So, yes. Tomorrow we'll do that. I have mentally मेरे को पता है कैसे करना है. और कुछ इसमें एक सीरीज को बंद कर देते हैं. बीच वाला मैं बताता हूँ. इस बटन को बस दबा देते हैं.